Hello, in this video we're going to learn about slopes and intercepts. I think we can all agree after graphing a bunch of equations last night or 2 nights ago that it can be a little time consuming by plugging in x values. So there is another quicker way to graph and to figure out information about a graph based on a couple values that we can look at. One of these values is called slope, and slope is a measure of how steep a line is, and it is basically the change, how y changes based on a change in x. And we call it rise over run, and the rise is how much higher. So I'm going to pick 2 points here. I'm going to pick, you want to pick any 2 points on the graph, but you want to pick points that cross grid lines, right? So I'm picking this one and this one because it's where it crosses a grid line. And so I want to figure out how much higher this point is than this point. And you can do it simply by counting. So if I go up 2, that's positive. Moving up is a positive movement. And so I would say, let me put a couple of these here. So I would say that goes up 2. And then the run is how far left or right. So when you go to the right, that's positive. So it's a right 1. So the slope of this line is 2 over 1. Okay. Now you could go down from this point to that point, and if you did that, moving down is a negative value, so you would say -2. And then moving left to this point would be -1. What you'll notice, if you look at these two different fractions that I made, 2 over 1, that equals 2. -2 over -1 also equals 2. So what I'm trying to show you here is that when you're finding slope from 2 points, it doesn't matter whether you go up from the bottom one or down from the top one. You'll get the same answer. Also, it doesn't matter which 2 points you choose. I could choose this point here, and I could choose this point here, and notice, let's make another equal sign here. Notice that I can go up 1, 2, 3, 4, and then I could go right 1, 2, and that would still equal 2 because 4 divided by 2 is 2. So no matter what 2 points you choose, and no matter whether you're going top to bottom or bottom to top, you'll still get the same slope. So the slope of this line is 2, and so I would just write equals 2. Another thing that we want to look at to describe this graph or to describe an equation is the Y-intercept, which we talked a little bit about yesterday. So the Y-intercept is basically where this line crosses the y-axis. And remember, here's the y-axis, here's the x. So this point this line crosses the y-axis at 0, 4, and so we would call this a y-intercept of 4. If you were asked for the coordinates, you'd have to put 0, 4, but if you were just asked for the y-intercept, you would put 4. The x-intercept of this one is at -2. We're not going to really worry about the x-intercept too much. We're mainly concerned with the y-intercept, and I'll show you why in a moment. Alright, now let's take a look at this green line. Again, if I wanted to find the slope, I'd go from any 2 points, so I'll choose this point here, and I don't know, how about this point here? So for the slope, we're going to do the rise, and that is 1, 2, 3. So the rise equal, whoops. So we're going to do rise over run. And so the rise was 3. And then the run, in this case, looks like it's going to be 1, 2, 3, 4, 5, 6. So 3 over 6. So we know the slope of this line is 1/2. Okay, so you can have a slope that's a whole number or a fraction. That's okay. The y-intercept of this line is, looks like -4, and the x-intercept is 8. Let's try a couple more. So notice these slopes here are positive. Now let's see what happens when we look at these slopes. So I'm going to pick 2 points again. So we're going to have rise over run. And in this case, I'm going to pick, let's pick this point here, and let's see, how about this point here? Alright, so if we go up 1, 2, 3. That's positive 3. And then we're going to go left. Now moving left, that's a negative movement, so it's negative 2. So what we have here is a negative slope, and you can write it as 3 over negative 2, or negative 3 over 2, or just straight up negative 3 over 2. And now let's take a look at this green one. So I'll pick 2 points here. I'll pick this one here, and maybe, how about this one here? Okay, so we'll figure out the slope here. So rise over run, and the rise in this case is, we'll start with this point here. The rise was down, so we're negative 2, and then the run goes to the right. 1, 2, 3, 4, 5, 6, 7, 8. So the run was positive because it moved to the right. And so we go negative 2/8, so that would be negative 1 over 4 when we reduce. So take a look at both of these graphs here. So notice the graphs that go up and right are positive, and the graphs that go up and left are negative. Okay? So we can also make a graph if we're given a slope and intercept. Oops, let me get out of that. Okay, so imagine, let's make a new page here. So imagine if I had an equation, or if I were just given a slope and an intercept. If I said the slope of a line is 1 over 3, and the y-intercept equals 2, we can use those pieces of information to make a graph. So let me pull out a graph here. Oops, that didn't work. Let's try that again. Alright, here we go. Alright, so here's our graph. If I know the y-intercept is 2, I know that the graph has to start right here. Okay, now if I know that the slope is 1 over 3, that means starting at any point I choose, which I choose this one because it's the only one I know, if I go up 1 and over 3, there'll be a new point. And then if I go up 1 and over 3 from that, there'll be a new point, and so on. So I can use the slope and the y-intercept to make as many points as I want. And notice going up and right would be the same as going down left. So down 1, left 3. So I can do that from here as well. Down left, down left, down left. And then I can make my line. So you can see that if you're given the slope and the y-intercept, it's really easy to graph. You don't have to do any math really. You don't have to plug in x and come out with y. You just plot the y-intercept and use the slope to plot every other point. So if we're given the slope and y-intercept, it's really easy. So wouldn't it be nice if every time we look at an equation, instead of looking at the equation, they would just give us the slope and the intercept, then we could graph it really easy. Well, let's go back and take a look at something. I'm going to tell you what the equation for these graphs are. So this first one, the equation is y equals 2x plus 4. And for this one, the equation is y equals 1/2 x minus 4. Okay, well, let's take a look at the important piece of information here. So we know the slope of this one was 2, and the y-intercept was 4. Notice 2, 4. Okay, let's look at this one here. The slope of this one was 1/2, and the y-intercept was -4. Look at that, 1/2 and -4. Very interesting. Okay, let's try the next one. The equation of this one was y equals -3/2x plus 3. Notice the slope was -3/2, and the y-intercept was 3. Very interesting. Okay, I'm going to give you one last equation here. So the equation of this one on the right is x plus 4y. Actually, that's not true. Let me fix that. I mean, it is true, but I want to change it. It's going to be 1/4 x plus y equals 2. Okay, so on this one, you're like, wait a minute, that's positive 1/4. Okay, but look what happens if I solve for y here. So if I subtract 1/4 x from both sides, and I get y equals -1/4 x plus 2, notice -1/4 is the slope and 2 is the y-intercept. So in fact, when we're shown an equation of a line, we're given those two important pieces of information to make the graph really quick and easy. Now, there's one thing that you have to do before, though. You have to get it in slope-intercept form. Y equals mx plus b, where m is the slope and b equals the y-intercept. Okay? So, basically slope-intercept form means solve for y. So once you have y all by itself, the number in front of x is the slope, and the number added to or subtracted from that is the y-intercept. So let's go back. So y equals mx plus b. I'll write it up here. Y equals mx plus b. So if the equation is solved for y, like it is here, down on the bottom, the slope is next to the x, is the coefficient, is what it's called, the number in front of the x term. So 2 is the slope. And then the intercept is what's being added or subtracted. So 4 was the intercept. Notice again, this equation over here to the right, solved for y, so it's in slope-intercept form. The coefficient of x is the slope, and what's being subtracted, or added, subtracted in this case, is the y-intercept. The only reason that this bottom right one didn't work initially is because, let me write it again, it wasn't in slope-intercept form. Notice this first form of the equation doesn't have y all by itself. It has this x term on the same side. Y has to be alone on one side to be in slope-intercept form, but once it is, all the information is essentially given to us right here. The slope and the y-intercept, making it very quick and easy to graph. So let's take a look at these 4 equations. I want you to pause the video and tell me what the slope and the y-intercept are for each of these equations, and then when you resume the video you can see if you were right. Pause now. Okay, so again, slope is m, so I'm just going to write it for each of these. M, 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 and then b is the y-intercept. So the first one, slope is 2, y-intercept is -10. Second one, slope, -3, y-intercept 9. Next one, slope, -2/3, y-intercept, -5 3/5. It's all given, it's all right there. Number 4, you have to make one quick tweak. I'll show you up here. You have to solve for y, so this 3 has to be subtracted, so you end up with this, and the slope is now right here, -3, and the y-intercept happens to be the same. That's it. Thanks for watching the video.